Good morning, Year 8. So today you're trying to complete a lesson on global atmospheric circulation. I wanted to give you a little bit of a video about these three questions. So why do we get atmospheric circulation? Why do we get high and low pressure, and where we get the most rainfall? So you might be watching this first, you might be watching this after you've looked at the PowerPoint, but hopefully it will help you. So I'm just going to scroll down to this point here. So this is a simplified model of atmospheric circulation. Now basically what it's showing you is that hot air is rising at the equator and then it's moving towards the poles and sinking. Okay, and it's a little bit like if you ran a bath of completely hot water and then, or you filled your sink with completely hot water and then you put cold water in it. Essentially, the cold water and the hot water will move around trying to share that heat out. Okay, it's because of pressure between the two. So what we essentially have is the sun is very, very concentrated on the equator. Okay, so at this point on the equator, the equator is getting direct sunlight, whereas up in the poles, the same amount of sunlight is actually spread over a much larger area. So it gets less intense heat. Just to put that in perspective, if you go to the Arctic, it's colder than it is at the equator. Now, because of that, this air is heated much more effectively than this air. And as this air is heated, the air becomes less dense, it weighs less, and it actually rises. Now, just to put that in perspective, a real life example, if you open your fridge freezer this morning or your fridge and sit below it, or you open your freezer, look at the bottom, you'll see cold air will fall out and sink and hot air actually rises. So this air rises, okay, and lots of the air rises, this air's all sinking, and what it does is it creates a movement of air from hot air rising to cold air that's sinking, and it gets moved around. Okay. How does that link to this pressure? Well, as the air rises here, so this is the equator, this is the pole, just put onto a different area. As it rises, imagine you were standing here and imagine instead of the air being just air, it was cardboard boxes. Well, originally all these cardboard boxes are sat on your head. As they rise, there's less weight on your head. So we get a low pressure here. But because this air is sinking at the poles, we get more cardboard boxes or parcels of air coming down and pressing on your head. Okay, you can't actually notice this difference, but the difference is enough to move air. So it becomes high pressure. Now, imagine you've got a tube of toothpaste. Okay, you leave the end open and you put your fist down on the middle, higher pressure. What will happen is the toothpaste will actually squirt out of the end towards the lower pressure area. If you put something under high pressure, it will move to low pressure. So what we get, this air rises, it heats from the sun, rises up, moves out, okay, and then sinks, goes back because it's high to low pressure. Okay, it's moving away from this area of high pressure like the squirted toothpaste, and again gets heated and rises, and so on and so forth. So if I go back up a little bit, that explains why we've got low pressure here, high pressure here. Where the air sinks, we've got this air weighing down on us, high pressure. Where the air rises, we've got low pressure. Now the final question is about rainfall. Now, if we get rain, what we need clouds forming in the sky. So we need some water, we need it to evaporate, we need it to rise, and we need it to condense. In order for air to rise, we need their low pressure. In order for evaporation, we need heating. Well, we actually get that at the equator, don't we? Okay, we get strong heating from the sun, we get low pressure, so we get air rising, and then that condenses above and forms massive clouds, and that's why we get tropical rainforests, we get thunderstorms here, or convectional rainfall we call it. And then towards the north, air is sinking, so we're not getting as many clouds. So that's why the Arctic is, yes, there's lots of snow, but it doesn't fall very much each year. Only a little bit of snow each year. It just builds up because it doesn't melt ever. Okay, so that's why we get rainfall. Now, these diagrams do explain it, but I wanted to talk through it as well because I think it can help. Ice desert, well, we're going to get that in the cold areas where the air is falling. Air is falling, so we're not going to get rainfall because you need evaporation, you need air rising up to form big clouds. So we're not going to get it here because the air is sinking, and it's cold because the sun isn't very concentrated here. The sunlight, sun energy. Okay, ignore the bit at the bottom. Don't worry about that. But hopefully that helps to explain why. Yeah, lots of heating, hot, rising air, rainfall, sinking air, no rain. Okay.